Now let's go over some important facts. First of all, the system now gives you a list of movies, but also it gives you all the guesses as to what your ratings will be in advance. And now we can go and choose a threshold of interestingness for showing a suggestion to the user. So, for instance, for Toby, we can say that only one movie, The Night Listener, was above 3 in ratings. So we'll just show this one movie. Or in a more realistic case, when we go with, let's say, Spotify song suggestions or Amazon books or Netflix movies, we'll just show, let's say, 5 top movies or above some kind of a specific threshold. And there is an important thing. We still have to remember that we can go by casting against a very prominent collaborative filterer, which means that if we have some kind of really a role model to look that we've identified as a top person who correlates with us the most, or who is the closest by the Euclidean similarity, then we can just look at his choices as well. So it still might be a good idea. And now, next up, let's turn tables and do matching for products. Let's see what this will yield us. We'll go over this one really quickly because we just want to basically see what the end result of collaborative filtering could also be. We don't go into that many details into all the formulas. When we do product-based collaborative filtering, our table is going to be products times users. Remember, Toby had not watched 3 movies. That's written here in the last column, not on the last row anymore. So essentially we have turned the table in a sense that everything that was a row before is a column now, and it's actually the other way around as well. So everything that was a column before is a row now. Okay, so this is our initial table. Now let's go to Euclidean similarities. Here they are, and now the first row, second column shows the similarity not between the first and the second user, but rather between the second and the first product. So Lady in the Water, Snakes in the Plane are similar to the extent of 0.02. Okay, so that's the one we're measuring now. And correlation is the same way. And now let's look at something here. Correlations are even negative. So let's look at this third and fourth. So third row, fourth column shows the correlation between down here Just My Luck and Superman Returns, and it shows a negative correlation of 0.31. So let's go to this negative correlation drawing, and it shows that if we take a look at Just My Luck and Superman Returns and put a linear regression line through it, we really get a downward sloping line with a negative correlation of 0.31. So this means that whoever values Just My Luck doesn't really value Superman Returns, and the other way around. So such things may exist as well. And now let's go to the final table. This final table does the same penultimate calculation that we had in the previous case as well. So it takes, let's just, without going deep into it, for instance, if we have product 1 user 7, it takes from the product times user table, it takes all the ratings that user 7 has given. And then from the Euclidean similarities table, it takes all the first product's similarities, and then it gets the score for product 1 user 7 by multiplying them one by one, and then by dividing with the sum of similarities. So it's essentially the same formula. Let's not go into that deeply. But what we get is now everything is product based. And what is the essence of it? The essence is as follows. Let's say that we have some kind of a sale where we have some kind of clearance in our shop, or we're really trying to determine how to get rid of that movie Lady in the Water. Then we can look at all the user scores for this product and determine that, it seems that user 2 has the highest rating for this product, and now offer this specifically to user 2. So to start concluding, we can say that user-based recommendation system suggests movies for a user to see. And then if we turn the tables and get a product-based recommendation system, it suggests users for whom to market the specific product. Now, where did we take the easy way? Or is it really so that Amazon.com has a system which really also predicts it just the same way described, or is it a more intricate algorithm? We did take an easy way at one point. Namely, we looked at user-based collaborative filtering. This is the name of the algorithm. In case of huge datasets, item-based collaborative filtering algorithm is used. And such an algorithm works very well if every user has seen just a fraction of all movies. So that might be a problem for us if we really have thousands of movies, thousands of users. As in real life, there is a problem for us when transactions are added real time to the data. Because remember, we had to calculate everything anew in that case. So the data set must have the ability of adding transactions all the time. And then this item-based collaborative filtering is better, which is a little bit more intricate, so we don't go into that. But for an application of it, let's now turn to SAP PA and R combination. So let's have, without doing it all ourselves in Excel, let's have it now in SAP PA.